So in today's lesson, there are a couple examples where we're graphing square root functions. So we have an equation where there's a variable inside the square root. And with anything, when you graph it, you could absolutely go and make an XY table and just pick some X values to plug in and see what you get for your Y result every time. The problem with that is you're kind of shooting in the dark a little bit. Not every X value is going to work in this function. The domain is not all real numbers. And you're going to get a lot of square roots of things that aren't perfect squares. If you can, you can punch them into a calculator, but there's a way to avoid all that. So I'm going to kind of outline sort of a strategy you can use to help you come up with convenient X values. Basically, you want whatever's inside this square root to be a perfect square, so that when you take the square root, you get a whole number. So I'm going to take whatever's inside the radical, and I want it to equal a perfect square. So the thing inside the radical is the same every time. It's always 2x. So the inside the radical column here is going to be 2x in every situation. And then perfect squares they're always the same numbers. Perfect squares, the 0 squared would be 0, 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16. We could keep going, but honestly, if you get 5 points plotted, you've done pretty well. So I would set up every problem in this manner. Whatever's inside the square root, force it to equal a perfect square. Notice there is no perfect square less than 0. You cannot have a negative number that is a perfect square using real numbers. Therefore, what this tells me is that by setting whatever's inside the square root equal to 0, I'm going to find an endpoint of my graph. This graph is not going to be infinite in both directions. So with that in mind, I can now make an XY table that's a little more informed than just sort of guessing random numbers. The numbers I want to plug in, I want to solve this equation to get an X value. Well, if I divide both sides by 2 to get my X value, I would get 0 as a result. Here, if I divide both sides of this equation by 2, I would get 1/2. Here, if I divide both sides by 2, I would get 2. Here, if I divide both sides by 2, I'd get 9/2, better known as 4.5. And here, if I divide both sides by 2, I'd get 8. So to get the y coordinates, I simply take, just like any equation, I take my x value and I substitute it in. I plug it in. So if I put a 0 in for x, 2 times 0 is still 0. If I take the square root of that, I still have 0. If I put a negative sign in front of it, I still have 0, and then plus 4. If I sub in a half, 2 times a half is 1. The square root of 1 is still 1. Then I make it negative, so now I have a negative 1 plus 4, and that's going to give me 3. Using the 2. 2 times 2 would be 4. The square root of that would be 2. Now you make it negative. You get negative 2 plus 4, and that's 2. You can kind of see what's happening in the table. If you put 4.5 in for x, 2 times that would be 9. And the square root of 9 is 3. Negative 3 plus 4 would be a 1. And we'll do one more here. Just putting 8 in. 2 times 8 would be 16. Square root of that would be 4. Negative 4 plus 4 would be 0. And now I have enough points to plot a decent graph. If you print off the graph paper, you're certainly welcome to do that. It'll be a little easier to graph it. If you don't want to print it off, or you can't print it off, you can certainly make a sketch here. You'll notice all the values in this table are positive. So I'm only going to be working with the first quadrant. I'm going to very carefully as my shaky hands can do, plot these points. 0, 4 would be right here. That's my endpoint, remember. 1/2, comma 3 would be, there's a half, 1, 2, 3. 2, 2 be about there. I need to get to 4.5 on the x-axis. 1, 2, 3, 4.5, comma 1. And then I got to get out to 8, 0. So that's 5, 6, 7, 8, 0. When I graph it, this is my endpoint. I'm not going to go through this point. Remember, 0, 4 is, you can't get into the negatives in this problem. Nothing's negative. So we've got to stop here. And my graph would continue this way, because I could continue plugging in x values. And my y values would continue to decrease. In the next example, they give us f of x instead of y, but that's okay. I'm going to treat it just like it were a y coordinate or a y variable. Once again, I'm graphing a square root function. So once again, I want to figure out what's the possible domain here. Well, what are some smart x values to use? So I want whatever is inside my square root to be a perfect square, so that I don't need a calculator and a bunch of number punching here. I'd rather have you think through a problem than punch through a problem. Inside the square root, every time we have x plus 3. So I'm going to generate some x values by setting whatever's inside the square root equal to perfect squares. And once again, the perfect squares, the least is 0. That's 0 squared, 1 squared, 2 squared, 3 squared, 4 squared. Those are the kinds of numbers I want to have as a result of figuring out x plus 3. So if I, by the way, this is going to give me my endpoint. If x plus 3 equals 0, that means x has to have been negative 3. If x plus 3 is 1, if I subtract 3 from both sides of this equation, I get negative 2 for x. If I subtract 3 from both sides of this equation, I get x equals 1. If I subtract 3 from both sides of this equation, I get x equals 6. And here I would get x equals 13. To generate the y values, I simply plug the x coordinate in for x in the function. So negative 3 going in for x, plus 3 gives me 0. The square root of that is still 0. 2 times that is still 0. Minus 1 gives me negative 1 for my y coordinate. That's going to be the endpoint of this graph. If I sub in negative 2, negative 2 plus 3 is positive 1. The square root of that is still positive 1. Times 2 is now 2. Minus 1 is 1. If I sub in 1, 1 plus 3 is 4. Square root of 4 is 2. Times 2 is 4. Minus 1 gives me 3. And if I sub in 6, 6 plus 3 is 9. Square root of 9 is 3. 2 times that would be 6. Minus 1 would be 5. And if I use 13, I get 13 plus 3, that's 16. The square root of that is 4. 2 times 4 is 8. Minus 1 gives you 7. You notice that the y-coordinates, since we picked these strategic values, the y-coordinates are increasing by 2 every time, which is frankly baked into the equation with this multiplier out front. In the previous problem, they were, in the previous problem, they were dropping by 1 every time, which was baked into the problem here with our negative 1 multiplier out front. So that's sort of a hint. If you pick these x values strategically, you'll see the y column of your table ultimately. I guess I should call this f of x. You'll see the y column of your table drop or increase by that multiplier. All I've got to do now is plot these points and draw my curve. So mostly I have large positive values and some negatives. So -3, -1 would be down here. That's going to be the endpoint of my graph. -2, +1 would be about there. 1, 3 is up a little higher. Six, 5. And then I got to get out to 13 on this axis. And up to 7. That's my endpoint. You'll notice both these graphs were basically half of a sideways parabola. Like if I reflected this, I would have a full parabola opening to the right. And the reason being is y equals x squared and y equals square root of x are inverses of each other, pretty much. You'd really have to take both the positive and negative branch. If you were going to solve this equation for x, you'd put a square root in, but you'd need a plus minus with it. So you really get plus minus square root of x for the inverse, which, since they're inverses, they'll tilt. The x and the y coordinates will switch. The reason that you don't get both branches is because of this. In this problem, they only asked for the positive branch, the +2. So that's why you only got the top piece of the parabola. In the previous problem, they only asked for the negative branch, which is why you got the bottom half of the sideways parabola. But yes, to summarize, you should be getting half a sideways parabola for these square root functions.